Hey there. Today we're going to start chapter 3, and this is on parallel and perpendicular lines. And we're going to kind of combine 3.1 and 3.2 together. 3.1 is really brief, it's just about lines in general, and then 3.2 brings in the parallel lines. And so we're going to focus a lot on parallel lines in this chapter. To begin with, let's just make sure we all know what parallel lines are. So parallel lines, probably you recognize, are lines that don't intersect. But it's a little bit more specific than that. They actually have to be they have to be coplanar points that do not intersect. They have to lie on the same plane, because we have this thing called skew lines. And they are also lines that don't intersect, but they don't intersect because they're not on the same plane. They're non-coplanar. That might be something new to you. And then we have something we call parallel planes. These would be planes that don't intersect. Let's look over here at this picture. When you look at this, let's find some parallel lines. Well, there's different ones here. You could say A and B. They're both vertical there. They make them lie on the same plane. Those would be parallel. These two red lines up here, they lie on the top, and they don't intersect. They're parallel. But skew lines would have to fall on different planes. Like the blue lines, if you look at this one here and this line here, these would never intersect, but they don't lie on the same side of that box. They lie on different parts of the box, and they still aren't going to intersect. Those are non-coplanar, and then we would call those lines skew lines. All right, so let's practice looking at this a little bit and see if we can come up with identify which ones are parallel, which ones are skew. So part A says, which segments are parallel to AB? All right, so AB is along the side over here, and we want to find lines that are parallel to that. Well, for it to be parallel, it has to lay on the same side, or on the same plane. So one obvious one might be this one over here. They both lie on the top. So I could write CD. And since they're asking for which segment, I'm going to go ahead and label that CD with a line over the top of it. All right, that's not the only one. AB also lies on the left face of this box, so EF would be a line that it does not intersect and would still be on the left face. Those are probably the easier ones. The trickier one would be GF over here. This is also parallel. Now, it doesn't lie on a side of this box, and it's hard for me to show in a video, but you could slice through from top left corner to bottom right corner, or not even corner edge, really. I could slice through a plane that would come through here and then come through down here. Those are parallel also. It doesn't show that plane, but there could be a plane that would go through both those. Those are the parallel lines. Now let's look at skew lines. Now we're looking at CD. So CD is this one. Now I don't want to pick out lines like that red line, those two red lines I have. Those would be parallel, but I want to pick lines that are skew. So they can't intersect and they can't be on the same plane. All right, so they kind of have to be headed a different direction. So like this is headed a different direction, but it hits right there at D, so that wouldn't work. Or this wouldn't work because it hits at D. But how about this line over here, AE? That wouldn't intersect. EH would not intersect with it, and it doesn't lie on the same plane. FG wouldn't intersect. It would lie on a different plane. FB over here wouldn't. So I think if I go these two vertical ones, and then these two kind of horizontal ones, those would be all of my skew lines. Everything else is going to hit that blue line. So let's go ahead and list those out. We said EH and FG, those two horizontal ones, and then AE and BF, those vertical ones. Those would be lines that are skew. And then it says, what are two pairs of parallel planes? This is a little bit of a refresher from chapter 1 when you had to name planes. Do you remember how many letters do you need to name a plane? Well, there's 3. You got to pick 3 from there. Now they only want, it says, it says 2 pairs of parallel planes. I'm just going to list one. Let's just pick one pair. Well, parallel planes are going to be on opposite sides of this box. from one another. So let's do the top and the bottom. So the top, I have B, A, B, C, D, and I just have to pick 3 of those letters. So I'm going to say, oops, I forgot. Put a little plane in front of it. Plane A, B, C. I just pick 3 of those letters. Don't need all 4. Would be parallel. Now here's a new notation. If you just draw 2 parallel lines like that together, we usually put them at a little slant. That means parallel. So plane ABC is parallel to plane, and then I have to pick out the bottom. And again, you just have to pick out 3 of those letters. I'm just going to go with F, G, and H. Those would be parallel planes. And then I could pick any other set of opposite sides of that box, and those would be parallel planes. This is the big thing that we're going to talk about in this section, is knowing some angle pair names. We've talked about like linear pairs, and we've talked about vertical angles and some, and now we have some new ones. And these new ones are always created by 2 lines cut by a transversal. And a transversal is a line that we have that just intersects through 2 lines. So I have my line L and my M, and every picture is the same here. And then I take this other line and I cut through those 2 lines. That's called the transversal. When you have 2 lines and you cut it with a transversal, it creates 8 angles. You can see all 8 angles labeled here. Those 8 angles, as we grab sets of those angles, they create a certain angle pair name. And we have names on this. So if you look at these 2 lines, we have angles that are inside of the 2 lines. These colored ones are inside, and then we have these ones that are on the outside there. Those are called exterior. So these are interior angles. The outside ones are exterior angles. And then once you decide if you're looking at an interior angle or an exterior angle, we also compare to where they are in reference to the transversal. Are they on the same side, like 4 and 5 are on the same side? Or are they on alternate sides of that transversal, like 4 and 6 are on alternate sides? All right, so the name kind of says it all. Let's look through these. Alternate interior angles. Okay, interior, so it's going to be those inside ones, the red and blue ones, and I'm on alternate. So that's what why they're made the same color here. 4 and 6, those are alternate interior angles. 3 and 5 are alternate interior angles. All right, and what we're doing here is we're grouping these 4 together and these 4 together. They're kind of close together, so they kind of merge, but we've got this set of 4 on top and the set of 4 on bottom that we kind of we're grabbing 1 of each. So here we got the next one is same side interior. So I'm still working on the interior angles, these 4 on the interior, but I want same side. So that'd be 3 and 6, or maybe 4 and 5. The next one, I'm going to jump down here real quick because I think it seems like these names say it all. This is alternate exterior. Exterior angles are on the outside of those 2 lines. So that's the 1 and 2 and the 7 and the 8. Alternate, meaning on the opposite sides of that transversal. So like 1 and 7. Those would be alternate. In alternate exterior. And 2 and 8 are alternate exterior. And the only one that maybe is a little bit trickier is this one right here, corresponding angles. Corresponding means that they lie in corresponding positions. So when you look at these 4 angles up top, and the number 1 there, to me that's like in the upper left corner of these 4 angles, upper left. So it corresponds to the angle down here that's also in the upper left, which would be 5. So 1 and 5 are in corresponding spots. The 2, that's upper right. So is the 6. 2 and 6 are corresponding angles. All right? All right, so just knowing those names, that was in 3.1. We're really going to do something with them in 3.2. Now, all of those angle pairs that we just named, they have a special relationship, but only if the 2 lines are parallel. And in that previous picture, they weren't. Those lines were not parallel. But now I'm going to make them parallel, and let's look and see what happens. So here's a picture, and this is a postulate. So remember, postulates are something we accept without proof. And we accept that same side interior angles, if the lines are parallel, then we're going to accept that the same side interior 4 and 5, I don't know why they changed the colors on us, but 4 and 5 right here, those are same side interior, those add up to 180. Those are supplementary. And 3 and 6, those are same side interior. They're going to be supplementary. Now that's only going to work if the lines are parallel. And we know the lines are parallel by this notation right here. Do you see that little triangle? When they put the little triangle on both the lines, that's indicating that the lines are parallel. Now this one I accept without proof. It's a postulate. That's the only one I'm going to accept. The others, I have to figure it out through a proof. And so let's try. I am proving here the alternate interior angle theorem, and so it's a theorem, so it can be proven. So I am going to prove here, I know that the lines are parallel, that's all that's given to me. I want to prove that 4 and 6, now notice it's not supplementary, that angle 4 and 6 are congruent. We're trying to show that the alternate interior angles would be congruent. All right, here's our process. Now, a theorem can be proven, and in order for me to use that theorem because I want to use it as a shortcut, I'm going to have to prove it once to you. All right, so first off, L is parallel to M. That's a given. All right, then the next one says the measure of angle 3 plus the measure of angle 4 equals 180. Well, look at 3 and 4. What type of angles are those two? That goes back a chapter, doesn't it? Those are a pair of angles that form a line. We call it a linear pair. And we have a postulate that says linear pair are supplementary. So I'm going to abbreviate that. We're going to use this one quite a bit. So we're going to look for some short notation. So linear pair are supplementary. That's how I'm going to write that. Linear pair are supplementary. All right, let's keep going. 3 plus 6 equals 180. All right, let's look up there. What type of angles are 3 and 6? Those are the same side interior. That's the postulate I just talked about. If you can get angle 3, or if you can get the lines to be parallel, then same side interior are going to be supplementary, and that's what this statement makes. So here's how we write that. We start off, and it only works if they're parallel lines, so we kind of show it. We say if, well, hang on, I forgot my if. If parallel lines are cut by a transversal, that's kind of my quickie, parallel lines cut by transversal. If I have that, I'm going to put a comma, then I'm going to run out of room here. I didn't leave myself much space. Same side, interior angles, supplementary. Now that's our postulate, and that's how we write it. Anytime that we want to specify that those same side interior are supplementary, we're going to write that right there. Now, on this next step, let's look and see what happened. We had this 3 plus 4 equals 180, and we have 3 plus 6 equals 180. Well, if they both equal 180, wouldn't they equal each other? Which is what this is saying right here. Here's my 3 plus 4, here's my 3 plus 6. Do you remember what that's called? When if they're equal to the same thing, they're equal to each other? That is the transitive property. And then, if you'll notice, they both have the measure of angle the measure of angle 3. Let's get rid of the measure of angle 3. Let's subtract it on both sides. And then you can see you have the measure of angle 4 equals the measure of angle 6. That's what's left after you subtract the 3. Okay, so then what did they do to get from there to there? Well, all they really did was get rid of the measure equal to just saying they're congruent. Now, as we progress through these and we learn more about these proofs and we have more steps in them, we start to do a few shortcuts. And this is one of those that I'll probably stop doing, this step right here, switching from equal to congruent. That's called the definition of congruent. That's what it means to be congruent, is that their measures are equal. So they're just switching from equal to congruent right there. But more importantly, what did I just prove? Well, I just proved that if you have the parallel lines, alternate interior angles are going to be congruent. And because I proved, we're going to name it. It's a theorem right here. We just proved it. It's the alternate interior angle theorem. And it says that if the lines are parallel, then alternate interior angles are congruent. Now I could do that with each one of these sets. I'm not going to do it. We've got two. We talked about the same side interior or supplementary. We did alternate interior or congruent. Alternate exterior are also going to be congruent. Now you can kind of think, if you're trying to decide if they're going to be congruent or supplementary, you know, supplementary angles, you're going to typically have one acute and one obtuse. But if they're congruent, they better both be acute, or maybe both be obtuse. So when you look at these, this angle 2 and this angle 8, these alternate exterior, you can see they're both acute angles. They're going to be congruent. Alternate exterior angles are congruent. And then the last one, corresponding angles are also congruent. They're the ones that lie in corresponding positions, like the upper right and the upper right. Those two are going to be congruent to one another. All of this works if you have parallel lines. So let's just practice with this a little bit and see if we can. It says, what are the measures of angle 3 and angle 4, and which theorem or postulate justifies that answer? Okay, so the measure of angle 3, if I find that one, and okay, all right, so the only angle measure they gave us, this is 105 right here. So on this 105, I have to decide with the angle 3, what's that angle pair name right there? Okay, they're interior angles, they're inside my two parallel lines, but they're on alternate sides. Now I'm not using this mess over here at all. I don't need all of that. I just need these parallel lines. And do you see, oh, I should have mentioned, see the triangles? That means parallel. If it's a double triangle, that just means it's a different set of parallel lines. So these are parallel, there's my transversal, 3 and 105 are alternate interior angles. And alternate interior angles are congruent, so the measure of angle 3 would also be 105 degrees. And my reason? If parallel lines cut by a transversal, alt interior angles congruent. It's that theorem, and we just write it out like that. All right, let's see if we can figure out the measure of angle 4. Now, this time I do need to be using this line over here because that 4 is created by these two lines. I think what I'm not using is this top mess because I got the 105 down here and I got the 4. So if I look at my parallel lines, and so I'm kind of looking at these parallel lines and this transversal right here. Look at the 4 and the 105. What's their angle pair name? Well, they're interior of the parallel lines, and they are on the same side. So they are same side interior. But if they are same side interior, what does that mean for them? Are you peeking back at your notes? You're supposed to be peeking back. Same side interior are supplementary. So if one of them is 105, then the other one is 75, so that they'll add up to 180. And my reason, if parallel lines are cut by a transversal, same side interior angles supplementary. All right, this is the same picture. I've just filled in what we found for angle 3 and angle 4. What I'd like you to do is go figure out all the rest of the angles. Everything's fair game here. You've got all those new 4 angle pairs, but we still know that linear pairs are supplementary, vertical angles are congruent. We can still use all the stuff that we've learned previously. Go ahead and pause the video and see how many of these you can figure out on your own. All right, here's what I've got. Check your answers, see if you agree. I'll go through it real quick where I came up with it, and there'd be 10 different ways to figure this out. But I went with 7 because vertical angles are congruent. Right here, I did linear pair are supplementary. That's how I got my 6 and 7. Vertical angles are congruent. And then I had to get up here to this 1, 2, and 8. So there'd be different ways to do that. I think I went with the 8 and the 75. These are same side interior. They're going to be supplementary. So 8 is going to have to be the 105. And then I could do the linear pair. So that's a 75, and then a vertical angle, that's 75. And ultimately, if you'll see that everything's either a 75 or a 105, and you can kind of tell from the picture even, if you had to choose, 5 is obviously an obtuse angle here, whereas 2 is an acute angle. And so if I'm picking between a 105 and a 75, that should help you kind of decide. All right, so let's try one that's a little trickier because we got some extra lines in here that are kind of weird. If you look at this, here are my parallel lines, but I have kind of two options for this transversal. I can either slice it through this way, here, or I can slice it through the other way. I guess I'm going to go ahead and leave that one since I marked it, and I've got this 80 degrees that I'm working with. If I look at my parallel lines and my transversal, this one is 80, but this, you look at my highlighted lines, this whole thing would be the other angle, and it's kind of split, so that's deceiving. But I marked it. You can see that these are same side interior angles, and same side interior angles are supposed to be supplementary. So if this one is 80, this whole thing over here would have to be 100. And if that's all 100, 40 of it's used up right here, what's left? Y should be 60 degrees. All right, this is our last one. It's a little bit fancier. It's a little, I don't know if I want to say trickier, but it seems deceiving because what you look at is when you see this as a trapezoid. Okay, but what we really need to be looking at and noticing is that this trapezoid has one set of parallel lines. And then I'm probably going to have to split up my work here. I'm going to start with this transversal right here. Okay, and with that transversal, they're asking me to solve for x and then to solve for y also. I'm going to start with just the x because I got lucky that I've got this angle here and this angle here that are what type? Practicing those angle pair names. Those are same side interior, and same side interior are supposed to be supplementary. So I'm going to do 2x plus x minus 12 should equal 180. And then I'm just going to do my algebra on that. Add the 12 to the other side and divide by 3. X ends up equaling, let's see, 64 it looks like. Okay. Why don't you take a minute and pause the video and see if you can figure out the y value. This time I use the green lines here, the parallel lines cut by transversal. They're really still same side interior. They're just on the other side of this thing. So same side interior are supplementary, so I set it up exactly the same way. And I got y to be 40. Part B says, what are the measures of the four angles in the figure? That's when you just start plugging stuff in. If I want to figure out this angle, I'm going to do 40 plus 20. That's 60. This is 3 times 40. That's 120. Let's do the x ones. It's 2 times 64. That'd be a 128. And 64 minus 12 would be 52. All right, so you can always just plug those in. All right, that's all I got for you. Good luck.